Hello everyone, now we are going to study about 2D arrays. Before we dive into what is 2D arrays or how we can represent 2D arrays or how to create 2D arrays, when we are in 11th and 12th, we know how to, we studied max. In max, we studied matrix, right? So matrix are nothing but collection of boxes which consist of rows and columns. So the horizontal origin is known as rows and the vertical axis is known as columns. So each box has its own location and the collection of boxes is known as matrix, and in the matrix what we are going to store, we will or we are going to store some data, right? So in matrices, in the boxes, some data will get stored. This is known as a matrix. So similarly in programming, we have one dimensional array, two dimensional array, and three dimensional array. So one dimensional array are nothing but elements with similar elements stored in continuous memory allocation, and it is in one axis, right? You can see that the element are is in one axis, whereas when the columns and rows when the columns and rows takes place when the columns and rows takes place, this is known as two-dimensional arrays. Here we have two dimensions, x-axis and y-axis. Similarly, you can imagine this in the form of a matrix. So similarly, we used to do in max, right? Matrix, we used to store elements, store data. Similarly, we can store elements and we can store data, and the vertical columns, the vertical things is known as columns, and these are known as rows. And we index will start in one dimensional array, we used to do indexing from zeroth index, right? 0 1 2 3. Similarly, the column and rows has its own indexes, right? And indexing will start from 0 1 2 3, 0 1 2, and rows for 0 1. So these are the representation of a two-dimensional array. So arrays in 2D matrix, in 2D form, or 2D, if we want to represent arrays in 2D form, then we called it as two-dimensional arrays. Similarly, we have 3D arrays, and we will store data here 2, 5, 7, 3. If you want to store data in three-dimensional form, then we use 3D arrays, and this is mostly used for graphic designing and RGB colors, and most of these things. And we have n number of arrays, right? We have 4D arrays, we have, and so on up to ND arrays, and we don't need to study all these things because this is not that much necessary for placements. We need to study only for first 1D and 2D arrays. These two things are very much necessary when it comes to placements, and 3D arrays we can study little bit, but these 3D arrays is very much helpful when we are going into competitive programming. 3D arrays is a little bit helpful for competitive programming, but most of the placement scenario 3D arrays is not asked that much. But 4D arrays and ND arrays, 5D arrays, 6D arrays is not that much necessary, and we don't need to study right now. Maybe if you are studying about in machine learning or artificial intelligence, ND arrays are used to store data in n dimensions. So when you are studying in future machine learning or data science, then ND arrays are necessary. So this is known as multi-dimensional arrays. Now let us consider how we can store array, how we can create arrays, or how we can locate a particular block in our two-dimensional arrays. So before we dive into how we can locate or create array, first of all, let us understand why we use arrays, why we need to store, or why we need to use two-dimensional arrays. So to understand why we use two-dimensional arrays, let us take an example. We all are students, and our teachers study. Our teacher teaches us fantastically, right? So suppose I want to store the marks, max marks, and physics marks, and chemistry marks. So how we can store? We can simply create array. If I want to store the marks of a particular student, let us consider that S1 student, then I will create max marks, after that physics marks, after that chemistry marks. So this is how I'm going to store my marks of a particular student, marks of a particular one student. Now here is the catch. Suppose I want to store the max of 100 students, marks of 100 students, or marks of 10 students. So creating 10 separate arrays, is not a logical way, and it's not efficient way, because if I create 10 arrays, then it becomes hard to manage and to locate or to access that particular arrays, that number of arrays. So to tackle that, we use two-dimensional arrays. I hope you have understood. So instead of creating 10 separate arrays, I will create arrays which are having 10 rows. So suppose let us consider that these are my student 1, student 2, will represent student 3, student 4 students. After that, columns will represent, each box will store marks, and columns will represent subjects: math, physics, chemistry, bio. So these are my subjects. So I can store here marks: 99, 98, 97, 93. After that, 100, 0, 0, -1, whatever you can store, right? 0, 99, 100, and 0, whatever. So this is how we use two-dimensional arrays. Another example is, suppose if I want to create a pixel. Pixel is nothing but, suppose if you are seeing a picture consists of thousands or millions of pixels. Similarly, videos also contains, right? You are seeing the video right now, you are seeing my lecture right now. That video also contains thousands of pixels. So pixels are formed on RGB combination, that is red, green, blue combination, and the range for RGB, each color is 255, 0 to 255. So if I write 255, 255, comma 255, this is known as white. And this one block of one column of 255, 255, 255 is known as one pixel. So if I want to store black, then I can write 0, 0, 0. This is known as black. This is known as black. After that, if I want to store only blue, then I can write 0, 0, 255. So this will give me blue. This is how we use pixels. So in picture are stored in the form of 3D arrays. So you are seeing a lot of pictures, right, in Instagram, Snapchat. So those pictures are formed of thousands of pixels, and each pixel is stored in the form of 3D arrays. So this is a pixel, this is a pixel, this is a pixel. So in this form, the RGB color is formed, and combining RGB color, we will get a single pixel. So this is the example of 3D arrays, and these are the example of 2D arrays. Suppose if I want to create a video, if I want to create my content, then video will contain a fourth dimension, that is a RGB three-dimensional array plus another dimension, that is time. So we don't need to study this much of things. To understand 2D arrays, you only need to understand these things. So by understanding why the need for using arrays, we can do a lot of problems, and we can do a lot of things. So I hope you have understood why we use two-dimensional arrays. So if I want to store 10 student marks, then I will just create a two-dimensional one array. Then I can store easily, and I can access easily. So let us understand how we can access a particular block in a particular given array. So to locate each block in one-dimensional array, we used to store elements from 0th index, right? It has 0th base indexing, 0 base indexing. Similarly, we represent these vertical things are known as columns, and these horizontal things are known as rows. So we will represent rows and columns with 0. So here total number of rows are 3, and the index starts from 0, 1, 2, and rows start from 0, 1, 2, 3. So here 0 base indexing also follows the same. Here you can locate each blocks as 0, 0. Here first of all 0, 1, 0, 1, after 0, 2. You can suppose you can locate this particular block as 1, 1. So first of all, here let us consider that this array, or two-dimensional array, is m cross n size. Here m will represent number of rows, and n will represent number of columns. So we will represent or locate a particular block first of all by writing the row number after a column number. So this is how we will locate a particular block in our array, two-dimensional array. Suppose I want to locate the arrow mark. So can I write that the location of my this particular block is 2, 1. So this is the location of this particular block. So I can access my particular block, data by through in one-dimensional array. We can able to access a particular element through its index, right? If I want to access, suppose it is, let us consider a one-dimensional array. This is my one-dimensional 1, 2, 3. These are my elements 0, 1, 2. Here, if I want to access the element 2, then what I am going to write? I am going to write ARR of 1. This will give me 1. This will give me 2. Similarly, suppose here the element is 3. Suppose the element which is stored here is 3. So let us consider that the two-dimensional array name is ARR. So I can access this particular element by its row number and the column number. So I can write ARR of square bracket. Here this is the first row, right? I am going to write first row. a square bracket rows, after it again a square bracket for column now. So the column number is 2, so I will write 2. This will give me these particular element, so this will give me 3. So this is how I can represent or allocate or locate a particular block in my two-dimensional array. So with that being said, first of all, let us code and see how we can create input, take input, output, and how we can update a particular array. For let me import my Java util bag, import java.util.star. After that, my public class, public static, sorry, public class Java basics, Java basics. In the class I'm going to write my function public static void main function. In the main function, string string args square brackets. After that, here I am going to create my two-dimensional array, right? To create two-dimensional array, we already know that to create a single dimensional array, we know that int name square bracket is equals to new int and that particular element size. Similarly, the same thing goes with two-dimensional array. So here I am going to write int arr. Suppose my two-dimensional array name is arr. I am going to give 2 square brackets is equals to new int. After that, in the square, again a square bracket, here again a square bracket, and in the first square bracket I am going to give the row, number of rows, how many rows are there in my two-dimensional arrays. Suppose I want to create 3 rows, after that 3 columns array. So if I want to create the number of columns are 3 and the number of rows are 3, then I have to give in 2 square brackets the row size and the column size. After that, we need to take input for this particular element, right? So this is how we create a particular array, two-dimensional array. So by just writing int arr is equals to new int square brackets in the parenthesis the size of my array, or in other terms, we already seen the conditions, different scenarios to create a particular array, right? Suppose this is the array we have created, right? Int arr 2 square brackets is equals to new int, and we have give the row size and the column size for my two-dimensional array. Suppose if I want to take input from my user for my two-dimensional array, then first of all, what I need to do, I need to build my scanner class. Scanner sc is equals to new scanner in that system.in, this is a scanner class. I have created the object of my scanner class. I am telling you that again and again that we will study about scanner class, different types of classes, objects in object oriented programming chapter. So with that being said, first of all, we have created our scanner class. After that, I am going to run my loop. Int I is equals to 0, and what is my row size? Row size is 3. So here I am going to give run my loop for, first of all, we will run our loop for row. After it, we will run our loop for column. So this is how that reversal works. So that reversal is, suppose let us consider that this is my two-dimensional array. So first of all, we will take input for my column element. So if the column is filled only, then and only I will come to my second row. If the second row columns are filled, then and only I will come to my third column. So this is how traversal works. So the input of my elements will take place as follows. So first of all, this element will get filled, after this element, after this element, after this one, and this one. So this is how the traversal of my two-dimensional array works. So let us take input from our user. Now in this, I am going to, the size of my array is 2, right? So this loop will run for 3 times. So I am going 0. We already know that for two-dimensional array, the indexing works from 0 base indexing. So I am going to start my for loop for I is equals to 0 and I should be less than or equals to 3. After that, I plus plus. This is my row. So the outer loop will keep track for my rows. After that, in the inner loop, I will keep track on columns, number of columns. So j is equals to 0, and remember guys that columns are represented with j and rows are represented with I as a variable. After j should be less than 3, after j plus plus. In this, what I am doing, I am going to take input from our user. So we already know that how to take input for integer, how to take input for a particular array. So how we can take input for array? We just write the array name, after square bracket. In the square bracket, we are going to give the index is equals to sc.nextend. Similarly, here I am going to give my array name after that my ith row, after that j column is equals to sc dot next int. This is how I can take input from my user. After that, whatever the output I have taken, I want to print it to my user. Here we need to remove int because we already declared our array, right? So after taking input from our user, I am going to print the whatever the value we have taken from our user. So I am going to start my loop. Int I is equal to 0 and I should be less than 3. After that, I plus plus. This outer loop will take care of my row, each row. After that, in the inner loop, what I am going to do, I am going to print my columns. So int j is equal to 0 and j should be less than 3. After that, j plus plus. In this, first of all, I am going to print my element. So how we can print element? So for array, we used to write array name after its index. Similarly, here I am going to write my array name after it ith row, after it jth column. Finally, a blank space. This is how we can print our array, two-dimensional array. And finally, after completing one complete column space, after that print a next line. So this is how the input and output takes place. So if I want to alter a particular index or a particular element in my two-dimensional array, then I can simply, I told you now that we can access a particular element in my two-dimensional array through its row and column. By knowing its row number and column number, we can access a particular element. So if I want to change a particular thing in my two-dimensional array, then I can write, suppose if I want to change the value of arr of 1 comma 1, then I will write the name, of my array. After that, its row number, column number is equal to something I want to change by it 2, then I will write 2. This is how the alteration in array works. If I want to update something or change something, then the change takes place like this. So we have successfully understand how we can take input from our user and how we can print the values that we have taken to our user. So let me save this code and run. So here first of all we have to give input. Let me give 1 2 3 1 2 3 3 cross 3, right? 1 2 3 4 5 6 7 8 9. So I have given the input to my user. After that, you can see that we have printed the two-dimensional array that we have given input to our user. So this is how the input and output takes place. Now let us talk about how memory is allocated in two-dimensional arrays. So before we dive into how memory is allocated in Java for two-dimensional arrays, I want to tell you a concept. That is, let us consider that this is a two-dimensional array, and in this particular array, the rows are greater than number of rows are greater than number of columns. So in this case, one scenario will take place, and that scenario name is row measure. Here we can see that the measure part is row. So when it comes to row measure, a memory is allocated in the form of rows. So these particular row will form a memory, continuous memory. So the elements, whatever they are in our row, forms continuously in memory allocation. After that, second row. After that, third row. Right? After that, fourth row. So the elements which are in the row takes place. Suppose let us take the address of this particular index as 1000. Address of this. After the next element will be stored in the 4 bytes. So the size of integer is 4, right? After 4 bytes, the second elements will take place. So 1004. After it, 1008. So this is how the first row address will take place. So in continuous manner, for the first row, memory allocation takes place. For the second row, there might be some gap, there might be some garbage space. After that, the second row need not to be in same order. So I can give us like 3000. After that, 3000. After the second element 3004 and third element 3008. Similarly, for the third row, in distinct manner, that is after the each row, the memory allocation need not to be in a pattern, it can be something else, but in the row the elements which are there will be in continuous manner. So this is known as row measure. This is the first scenario. We will have. After it, in the second scenario, column measure. So in the column measure, if my columns number of columns is greater than the number of rows, then the memory allocation takes place for columns. So I am writing in the form of rows, but these are actual columns. So here the columns are 3, right? So 3 columns will take place, and the elements which are there in the column will allocate memory in continuous fashion. In continuous fashion, after column 1 is completed, column 2 will take place, and the elements also take place in continuous fashion. After it, in column 3, similar thing goes on. But remember guys that the address of the last element in my first column, let us consider that it is 1008. After it, in the second column, the first element need not to be like 1012. It can be 2004. After it, the second element can be 2008. So different columns may have different storage classes or different addresses, but the elements which are there in the column stores memory in the form of continuous fashion. So this is known as row measure and column measure. This is the concept of row measure and column measure. And majority of languages like C language, Python, C++, all these languages follow row measure and column measure scenario for two-dimensional arrays memory allocation. But when it comes to Java, uh, row measure and column measure doesn't take place. So Java doesn't follow row measure and column measure. I just wanted to tell you the concept of row measure and column measure, such that you can use it the concept, or when an experienced programmer asks you some questions, then you can answer what is row measure and column measure, all those sort of things. So remember guys that in Java, row measure and column measure, these concepts are not there in Java. So when it comes to two-dimensional memory in Java, memory takes place randomly. Suppose let us take that this is our two-dimensional array, right? This is our two-dimensional array, and the address of this particular block is 2000. And the second block need not to be 2004. It can be like 5000, and the third block can be 3000. Whatever randomly memory allocation takes place, wherever the free space is there in our computer, at that location, two-dimensional arrays memory takes place. So remember guys that in Java, two-dimensional arrays memory allocation need not to be in continuous fashion. It might be in some scenarios, but remember guys, that's not the always condition. In most of the cases, memory allocation doesn't takes place in continuous manner when it comes to two-dimensional arrays. So sometimes by chance or coincidentally, it might take place in continuous fashion, but it can't take place always, right? So this is the concept of memory allocation in Java. I hope you have understood that memory allocation does not take place continuously when it comes to two-dimensional arrays, but when in the case of one-dimensional array, memory allocation takes place in continuous fashion. So this is the difference between one-dimensional array and two-dimensional array. Now in the next slide, we are going to do an interesting question which is really important when it comes to concept wise, and this is a classic question. So in this particular question, user has given me a two-dimensional matrix. Now this is a classic question. You can find it in many placement scenarios, and you can find this question in LeetCode, HackerRank, and many more platforms, coding platforms. So this is a classical question and at the same time important question. Now in this question, user has given me a two-dimensional array, and we have to print our output in the form of a spiral matrix. So what is spiral? Spiral is like this kind of diagram. I want to print the elements like in this fashion. So here in this fashion, I want to print the elements like in this fashion. So the output will be 1 will be printed first, after 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 8, 7, 11, and finally 10. So I want to print the our elements in this spiral fashion. So this is the basic asking or basic need for our question. So this is the main concept of the question. Now the thing is, what are the things we have to understand to do this question, or what is the logic behind it? First of all, I want you guys to observe one thing. First of all, let me erase all these things. Now I want you guys to observe one thing, that the output, the output you are observing, right? So this is my first loop, right? This is my first spiral. After that, this is my second spiral. Can I say that this is my first spiral and this is my second spiral? So before we dive into question, let us take a sample example, sample two-dimensional array. Right, this is, let us consider that this is my two-dimensional array. So can I write that this is my starting row and this is my ending row, right? This is my starting row and this is my ending row. Similarly, this is my starting column and this is my ending column, right? Starting column, ending column. Can I say that? So here you can see that my number of rows are 1 2 3 and number of columns are 1 2 3. So 3 cross 3, this is a 3 cross 3 matrix. So here the starting row will be 0, right? And the ending row is I told you now, arrays will take place on 0 base indexing. So 0 1 2 0 1 2. So the ending row number will be 2. After that, in other words, I can write that the total length, the total number of rows minus 1. The total number of rows are 3 and minus 1, right? Similarly, for columns, I can write starting column is equals to 0 and ending column is equals to 2, or in other words, number of columns minus 1. So can I write this? Yeah, absolutely, this is correct description or demonstration of this particular diagram. So can I say that this is my starting row and this is my ending column, ending row, and similarly this is my, for the given question, this is my starting column and this is my uh, ending column. So you can see one pattern that first of all I am printing my one element, after it 2, after it 3, after it 4. You can see that I am starting my loop from starting column and I am ending it at my ending column. After it again from the ending column I am going, and finally from the ending column, or in other words starting row to ending column I am printing, and from ending column again I am increasing or decreasing my value of rows, columns. Here I am traversing from column wise, here I am traversing from row wise. So in this I can write that I am traversing my elements or my two-dimensional array indexes from ending column to my starting column. So let me erase this such I want to write in clear format. So this is my starting column, this is my starting row. After that this is my ending row, starting column, ending column, right? I am starting, first of all I am starting at 0th iteration. We are using loops, we will use loops to solve this particular question. So at the 0th iteration, that is nothing but my first iteration, I am starting my row. So this is my top, and this is my right, and this is my bottom, and this is my left, so these are the terminologies that we have to understand first of all to solve this question. Now at the 0th iteration I am starting from, so you can see that this is my first loop, or in other words you can say this is my first spiral. So in the first spiral what I am printing, I am printing 1 2 3 4 8 12 16 15 14 13 9 5. So these are the elements that I am printing in my first iteration or in my first spiral. So my starting row will be 0. In my first spiral starting row is 0. After it where I am going from starting to ending. So can I write n minus 1? Let us consider that number of row is n. So I am traversing from n minus 1. So from this I am coming right like this. So the indexes are 0 1 2 3. After that 0 1 2 3. So from 0 to I am coming 3, right? You can see that I have printed 1 5 9 13. So you can see that I am traversing from row wise. So initially in my 0th iteration my starting row is 0. After that my ending uh, row is n minus 1. After that my starting column is also 0 and my ending column is, let us consider that it is m is the total number of columns, and I am traversing from m minus 1 times, that is nothing but 3. This is my first iteration. After that in the second iteration, what I am doing, I am increasing the value of so this is my starting, right? After it what I am doing, I am printing 1 after completing one spiral I am printing 6. So my iteration in the second iteration starts from 6, 7, 11, 10. So my starting index will be pushed by 1. That is a start plus plus. So my starting row will become 1 and starting column will become 1. You can see that my ending column, you can see that ending column is 3, and you can see that my final output is 10 here. So what I'm doing, I'm decrementing the end row. That is I'm doing end minus minus. So I can write n minus 2, that is nothing but 2, and column n m minus 2, that is nothing but 2. So you can observe one thing, that somehow I need to increase my starting row, and I need to do starting row plus plus. After that I need to do starting column plus plus. So for starting things I need to increment it at every completion of a spiral. After that, for my ending row I need to decrement it at each and every iteration, right? After that uh, similar things goes for column. So I need to decrement it at every iteration for a particular spiral. So this is the concept here. And remember guys, that this is my top, this is my right, this is my bottom, and this is my left. Top, right, bottom, and left. So the overlay or the structure of my pseudocode will be, first of all, you have to observe one thing, right? Suppose let us consider that here we have another element, so we will print this element right here. The final condition is here, suppose let us consider that we have another element, then the condition is while our starting row is less than or equals to ending row, right? And similarly starting column is less than or equals to ending column. So this is the condition. So I am running my while loop for n number of times. So while will take off number of spirals. So this is my first spiral and this is my second spiral, first spiral, second spiral. So while keyword or while loop will take care of number of spirals. After that, in the while loop I need to print my top. So here I am going to, let me change my pen ink first of all, such that you will differentiate things. So I am choosing black color. Yeah, see, first of all, this is my top, right? So this is my top. So for top I need to create a for loop. For top, a separate for loop, and for uh, right, so this is the fashion I am working, right? So first top, after that right, after that bottom, after that left. So this is the fashion I am following. So for top, first of all, our loop starts from int. We are traversing column wise. So what I told you, for column wise traversal, we use a variable j. So our j will start from j is equals to 0, and j should be less than uh, column, our number of columns, or j should be less than or equals to n minus 1. That is nothing but m minus 1 is nothing but total number of columns minus 1. That many times I am running my for loop. After j plus plus, in that I am printing my elements. This is how I will take care of my top. After that, what I have to print, I have to print my right. For right, you can see that in the loop I am traversing, in the top loop I am traversing, I have printed 1, I have printed 2, 3, 4. So I am coming n minus 1. I also print here, you can see that j should be less than or equals to. So this element will get printed. So my for loop will start from uh, int j, int I, this is the rowest traversal, right? So I will start from 1. After that, j should be less than or equals to n minus 1. N represents number of rows, right? After that, I plus plus, and I will print the elements in between. Whatever the elements I have, I will print. After that, now I need to print my bottom. So for bottom, our loop starts from this. Again, this is a column wise traversal. So for column wise traversal, int j. So I am starting with my end column. This is my end column. So in the right iteration, I have printed 16. So I need to start from here. So I will start my j is equals to n minus 2, and j should be greater than or equals to 0. So I will come here. After that, what I am doing here, I am doing j minus minus, and whatever the elements I have, I will print here. And finally, I am going to print my left. I am going to print my left. So for left, we are writing for, you can see that row wise reversal. So int I will start from, I have printed my end row, so I will start from the top of my end row. So I is equals to n minus 2, and I should be greater than or equals to 0, and I minus minus. Here what I am doing, I am printing whatever the elements we have in between the particular row. After completing the top, right, bottom, and left, after completing one spiral, I need to decrement this thing. So what I told you that we need to do after completing all the loops, top, right, bottom, we need to do this. So we need to increment start, after that we need to decrement end. So this is how the pseudo code for the spiral question works. Now let us code this thing. Now first of all, let me create my function public static. This will print, right, so it will return nothing. So void, the function name is spiral matrix. In that I am passing my array, two-dimensional array, err. After that this, now the thing is I need to store the number of rows and number of columns. So to do that I am going to create int n is equals to arr dot length. So this thing will give me number of rows. After that, for number of columns, int m is equals to arr of 0 So the first array, whatever the elements present, that will give me finally my number of columns. Right. After that, I am going to create my start row is equals to 0. After that, start column, int start column is equals to 0. After that, int end row is equals to n minus 1. Total number of rows are 1, right? So number of elements which are present is n minus 1. After that, int end column is equals to m minus 1, right? After that, I am going to write my while keyword, while our start row should be less than or equals to end row, and logical and. After that, my start column should be less than or equals to end column, right? In this, first of all, I need to print my top. So for top, I'm running my for loop for int j is equals to 0. After that, j should be less than or equals to end column, end column. After that, can I write in the place of end column as m minus 1, right? Okay. After that, j plus plus. Here what I'm doing, I'm printing my system.out.print. Let me remove ln. I'm printing my array, that particular element which is present at that particular box. So arr of I, arr of j. Right here, in the place of I am going to print my starting row, because the row here is starting row, right? After that, a space, a blank space. So the top is get set now. After that, I need to take care for right. For right, I'm going to start for int I is equals to starting row. After that, I should be less than or equals to n minus 1. After that, I plus plus. Here what I'm doing, I'm printing my elements which are present in my row wise reversal right side. So print err of end column. This is a end column, right? End column. After that, I, here I end column, right? Another space. And for here for bottom, now bottom. So for bottom, I am going to write for int j. Now our j will start from n minus 2. So n minus 2. Here I can write it as a end column minus 2, end column minus 1, because the end column is m minus 1, right? After that, j should be greater than or equals to 0, and j minus minus. Here system.out.print, I am printing my elements present here, end row. After that, j, and finally my left. For my left, I am doing for int I is equals to this is the end row, right? So from end row to top row, so I can write for my end row minus 1. After that I should be greater than or equals to 0. After that I minus minus. Here I am printing system.out.print uh, system.out.print here ARR of particular index. After that start column and a space plus space. Save this thing, and here I can write my end column, right? Here I can write my end row. Here I can write column wise, right? So end column. After completing all the left, right, bottom, left, top, what I'm doing, I'm incrementing the start values. So start column plus plus. After that start row plus plus, and decrementing the value of end column minus minus, end column minus minus. After that end row minus 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 minus. Save this thing and run. Now here let me give the array which is provided as example. So I'm going to create my array int arr. Two-dimensional array is equals to the size of array is 4 cross 4. In our previous example, the size of the given array is 4 cross 4. So I'm creating a 4 cross 4 array. 4 4. After that I am running my for loop. Before that, let me create my scanner class. Scanner sc is equals to new int new scanner in data system dot in. After that I'm running my for loop for int I is equals to 0, and I should be less than arr dot length. After that I plus plus. Here in the inner loop for int j is equals to 0, and j should be less than arr of 0 dot length. After that j plus plus. Here I am taking input from my user. So sc arr of I comma j, arr of ij is equals to sc dot next int right? So I'm taking input from my user. After that I'm calling my function, that is spiral matrix, and I'm passing my array, which is the values of array is taken by our user. The array we have here are the elements from 1 to 16, and you can see that the output is 1 2 3 4 5 and so on. Now let me save this and run. So I have to give numbers from 1 to 16 as my input. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, right? I have given input for my user. After it here what it is printing, wait a minute, I need to give a next line here. System.out.print in the right starting row, in the right, you are starting from starting row right? Okay, starting row plus 1, right? Similarly here we are starting from starting row. Similarly here ending row. Yeah, so this is how. So in the place of 0 I need to give starting column. After it, in the place of starting row, in the place of 0 for I integer, I need to give start row. I need to give a space here, right? Now everything is sorted. Now save this and run. I'm giving input 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16, and run this. You can see that we have got our output 1 2 3 4 5 12 16 15 17 18, and here in the place of this these things are printing because in the place of 0 I need to give starting starting column. After that, in the place of this, I need to give starting row plus 1. Save this thing and run again. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 14, 15, 16. Now you can see that we got our output. This is the spiral fashion that we decide that we wanted. So this is the code. So in the place of 0, I should be greater than or equal to 0. We need to give starting row. After that, in the place of j should be greater than or equal to 0, we need to give starting column, because here the starting column is changing, because you can see that initially starting row is 0. After iteration, starting row will become 1. After that, starting column will also become 1. So this is how the working of spiral matrix works. In this question, we have to give the diagonal sum of the given diagonals. So this first diagonal is known as primary diagonal, and this is known as secondary diagonal. So the student who studied maths might already understood the pattern in this question and how we can calculate the diagonal uh, sum of the primary and secondary diagonals. So here there is one condition that the given a matrix should be a square matrix. What is mean by square matrix? If the number of rows is greater than number of columns, then it is known as a square matrix. So this is also an important question, and this is this also has a significance when it comes to competitive coding. Now let us understand how we can do this question. Now let us take a example array, for example, and this is our array, and these are the indexes 0, 1, 2, 0, 1, 2. Now this is my primary diagonal and this is my secondary diagonal. So can you observe one thing, that in primary diagonal, this is the most important thing of this question, right? So in primary diagonal, the row number and the column number, and in the third element, row number and the column number. Can you observe that if a diagonal is a primary diagonal, if a particular diagonal is a primary diagonal, then I can say that my row number is equals to my column number. If this condition is true, then the provided element is a part of my diagonal element, right? This is the first condition. So we have solved the first condition for primary diagonal. After that, for secondary diagonal, let me write the indexes here: 0, 1, 2, 3, 0, 1, 2, 3. So here the location of this is 0, 0, 1, 1, 2, 2, and 3, 3. Now in this the location of fourth element is 3, 0, 3, and 1, 2, and 2, 1, and 3, 0. So these are the locations of my primary and secondary diagonal. So we have already found out the condition that for a particular element that has to be a part of primary diagonal, that the condition should be I is equals to j, that is the row number should equals to the column number. If this condition is true, then the provided element is a part of primary diagonal. For secondary diagonal, can I observe one thing, that is 0 plus 3 is equals to 3, and 3 is my number of columns, or you can say that is n minus 1. So can I say one thing, that 0 plus 3 is equals to n minus 1, that is number of rows here or number of columns here is 4, right? That is n is equals to m. So can I write n minus 3 is equals to m, and 0 plus 3 is equals to 3. After that, 1 plus 2 here, 1 plus 2 is equals to 3. After that, 2 plus 1 here is 2 plus 1 is equals to also 3. After that, 3 plus 0 here, 3 plus 0 is equals to 3. So can I say one thing, that for a particular element, if it has to be a part of my secondary diagonal, then its sum I plus j should be equals to n minus 1. If this condition is true, then it is a part of secondary diagonal. So I have find out the cases when a particular element that can be a part of primary and secondary diagonal, and what are the conditions, what are those conditions we have derived logically. Now let us write the pseudocode for this question. Now we need to run two loops. We need to run two loops. So the time complexity for this particular question will be big of n square, and there is an efficient way for doing this particular question. We'll study about it later. Now we need to run two loops. One loop will take care of number of rows, and inner loop will take care of number of columns. So the pseudocode will be, first of all we will create int sum is equals to 0. After that we will run our outer loop for int I is equals to 0, and I should be less than n, that is number of rows. After that I plus plus. Here in the inner loop I am running for int j is equals to 0, and j should be less than m. I can write n or m because the question is provided for a square matrix, so n and m are same, so I am writing n. After that j plus plus. In this I am checking whether my particular element belongs to my diagonal element, primary diagonal, or my secondary diagonal. So if a particular element is a part of diagonal, primary, whether it may be primary or secondary, I need to add that element. This is the logic here. I need to add that element. If that particular element, whatever the element we have, if it is not part of either primary or secondary, then just leave it. Don't do anything to that, right? So I'm writing my if statement. In the if statement, I'm checking if my I is equals to j. If this condition is true, then what this condition will tell me, this is a primary diagonal. So if this is a primary diagonal, then I am doing sum is equals to sum plus ARR of I j, right? After the second condition is else if my I plus j is equals to n minus 1. If this is the case, then my sum will become sum is equals to sum plus ARR of I plus j, right? This is the condition for secondary diagonal. So this is the condition. First condition is for primary and second condition is for secondary diagonal. Now let us calculate manually how we can calculate the sum of the given question. So here 1 plus 6, that is 1 plus 6 plus 11 plus 16, 11 plus 16. After that 4 plus 7 plus 10 plus 13 plus 4 plus 7 plus 10 plus 13. So whatever the sum we have, let us calculate 7 plus 11 plus 16, 7, 27, 27. Here it will give 11. After that it will give 11 plus 23. After that 27 plus 7, 27 plus 7, 14, 34, 34 plus 11 plus 23. So this will give 23 plus 11, 4, 34. So 34 plus 34, the final answer will be 68. So we have to print the value of 68 to my user as my answer. So this is the pseudocode for this question. Now let us code these things such that we will understand the logic and the things what are going on even more better. So here I am writing my diagonal sum. The above code is for checking spiral matrix. The above code is for checking spiral matrix. Now we are writing the function for diagonal sum. Here, now first of all let me create my function public static void type function, no, integer type function, because it will return the sum, right? After that my function name is diagonal sum. In this I am passing my array ARR, two-dimensional array. After that in this I am calculating the number of rows, right? So int n is equals to ARR dot length. So the only condition for this question is the provided array should be a square matrix. So I'm just calculating the number of rows. We already know that for a square matrix, number of rows is equals to number of columns. So I'm not separately calculating number of columns here in this question. After that I'm running my for loop for int I is equals to 0, and I should be less than n. After that I plus plus. In the inner loop I'm checking for int j is equals to 0, and j should be less than n. After that j plus plus. In this I'm checking whether my element belongs to my primary diagonal or secondary diagonal. If any of this condition is true, then add to my sum. So before this running loop I am creating my sum variable int sum is equals to 0. After that I is equals to j. This is my primary diagonal condition. Then sum is equals to sum plus ARR of I after that j. After that else if condition, else if I plus j is equals to n minus 1. Then sum is equals to sum plus ARR of I, ARR of j. Right, finally return the value of sum. Return some value. Right, that's all. This is my pseudo code. This is my actual code. Now let me run my code here. I am passing my function, and in the place of calling spiral matrix, now I am calling my diagonal matrix function. So diagonal matrix function, and I am passing ARR, and whatever the value I got, I am printing it. System.out.print plus a space. That's all. That's all I am printing. I can write also here that sum or diagonal sum is, right. That's all. Now save this thing and run. I am giving the input to my user as 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Now you can see that my diagonal sum is 68. We have manually calculated how we can calculate diagonal sum, and the answer we got there is equals to the answer that computer gave me. So this is the code for calculating the diagonal sum of an element.